Thank you. I might just leave this slide up for a moment because I think it gives a pretty good visual representation of what we do at Neara. So at a high level, Neara is quite heavy enterprise SaaS. More specifically, it's a platform that creates engineering grade 3D digital models of critical infrastructure. So to date, we've focused on the electric utility industry, but the platform itself is actually vertically agnostic and can be applied from anything to telecommunications towers to trains. We loosely play in the digital twin space, although to be perfectly honest, we don't really like that terminology. In our view, that's a term that's been bastardized to some extent by software vendors that provide very pretty visualization with quite underwhelming functionality. So Neara essentially solves a trade-off. So on the left-hand side of the screen, you can see that historically you could have performed engineering grade analysis using Excel spreadsheets, PDFs, and desktop-based software on one individual asset. On the other hand, you could perform very superficial analysis across your entire network. And this is the trade-off that Neara solves. So customers use Neara to perform complex engineering grade analysis and physics simulations at an individual asset level, and then extrapolate that analysis over their entire network. So for example, one of our customers might come to us and say, I have 200,000 kilometers of network. Show me which specific conductors are at risk of clashing and starting a bushfire. And Neara can answer that question with the press of a button. How do we do that? At a high level, we take whatever data the customer has available from time to time. So normally this involves some sort of GIS, LiDAR scans, which is essentially a laser scan of a customer's network. We can overlay satellite imagery and use IoT data. Any old maps, whatever the customer has, we'll put that into our automated network builder. It will automatically build a network model, and then we use that model to provide a range of different solutions to the customer. It's worth noting that we provide solutions across a range of themes, but given the audience today, I'd like to focus on themes 4 and 5. Probably worth calling out that network health and reliability has traditionally been the kind of bread and butter of the platform, and recently we're seeing strong growth in the climate space. The scope of the network health and reliability theme has been enormous for our customers. So one customer saved $5 million in OPEX in the first year of deployment by replacing manual asset inspections with analysis on the platform. Theme 4 here, weather resilience and grid hardening. So customers use Neara to run simulations over their network to identify weaknesses. And theme 5, renewable energy and decarbonisation. So our customers use these types of solutions to accelerate their energy transition. Some of you might be wondering what power lines have to do with the energy transition. Really the key constraint as we see it, linking both demand and supply side factors for the energy transition, is a lack of network capacity and access in the grid. And that is the key that Neara unlocks. So how does Neara actually unlock that? Well, we think about it in 3 stages. The first stage is unlocking the existing capacity in the network. So we use static line rating and dynamic line rating solutions to unlock existing capacity without requiring any additional infrastructure spend. The second kind of lens we use is protecting existing infrastructure. It's really no use optimizing your existing infrastructure if you can't protect it from extreme weather events. So there's 2 sides to these kinds of solutions. One is in advance of an extreme weather event, the customer can run a simulation and identify which individual assets do I need to either strengthen or replace so that I don't have to gold plate my entire network. Then once an extreme weather event is occurring, customers can use these types of solutions to respond more efficiently and protect the assets and the communities. And the last one is accelerating the construction of new infrastructure. So Transgrid in New South Wales is currently using our transmission design and route optimisation solution for their HumeLink project. Put simply, this brings renewable projects online sooner. Now, I did have I get very excited about power lines, and I did have quite a long and technical explanation of line rating. I will spare you that before we have our afternoon coffee. But put simply, when we talk about line rating, we are talking about the amount of current that you can put through a conductor before it reaches its maximum operating temperature. If that happens, bad things occur, so the line will heat up and sag, which can breach clearance levels. The conductor itself can start to degrade. So this is a screenshot of our static line rating solution, which Essential Energy has recently deployed in New South Wales. Now, the true line rating of a network has historically been unknown because we're talking about very critical infrastructure. In the absence of knowing the true line rating, networks had to make very, very conservative assumptions about the temperature that their assets could operate at. Using Neara, Essential has recently discovered that instead of issues arising when a conductor reaches 50 degrees, in most cases, no issue arises until the conductor reaches 80 degrees. So what does this all mean? I'm sorry for going deep into power lines, I got a little bit excited. If there's one thing you remember from this presentation, please let this be it. So this allows more renewable energy to be brought online without any infrastructure spend required. So in the case of Essential, what they have found is that their network capacity was actually double what they had previously thought. Even static line rating has to make some conservative assumptions, and most of those assumptions are made about the weather. So for example, every summer day is assumed to be sunny with no clouds and minimal wind to cool the line. There was space for me to make a joke about Melbourne weather, but it's actually a really nice day out there. So this is our dynamic line rating solution, and to put it simply, it allows an operator to take all those different variables into account. You'll see at the bottom of screen, there's manual inputs that can be made by an operator, but this can also link to IoT hardware installed on the transmission line themselves or link to weather stations. This is our flood solution. So again, in this second lens of protecting existing infrastructure, what we do here is figure out the relevant flood level and then calculate the clearance from the live electricity conductors to the relevant flood level. And then we extrapolate that across the entire network. So interestingly, this also gives a snapshot into the competitive advantage of a 3D model over a 2D model. So the screen on the left there is a 2D model that will tell the network your asset is affected by floodwater. Kind of helpful, not particularly helpful. The one on the right is our flood model, and if you look towards the bottom right of the screen, you can see that even though the distribution poles themselves are partially submerged, the spans have been coloured green and yellow. So that is telling the network operator that there's still sufficient clearance that you can keep that span online. South Australia Power Networks recently used this during their own floods, and they managed to bring back power to communities 3 weeks ahead of schedule using that kind of technology. Last of all, we all know that transmission and specifically transmission builds are necessary, but they're also very slow and complex. One of the reasons for this is that everybody involved, so governments, policymakers, the network owners, the construction companies, and the communities themselves are all working off different models. Most of the time, the data is unreconciled and sometimes corrupt. So we've heard stories of route plans, including plans to build transmission towers on people's driveways because the model data was wrong. So Neara simply gets everybody on the same page. This solution can be deployed prior to any build at the very start of the process. So you can generate a feasibility study, which is engineering grade, and can include fully costed route optimization and, importantly, different options for a route of a build. That cost can also include tree removal and community impacts. Then prior to a build, you can use this solution to confer with landowners. So in that case, if you were to get this solution up on screen, if a landowner has an issue about the location of a particular tower, what you can do is just click and drag the transmission tower, and the network model will automatically update the engineering and any cost consequences that change has. Then during a build, what we're seeing in HumeLink is that all the construction companies involved are being brought onto the platform so that everybody is working off the same model. And so you can imagine that all of those little efficiencies that you can build into the process can hopefully bring those projects to completion earlier, which brings more renewable power online sooner. I just included some traction metrics here. So we currently have 65% of the market in Australia done by network length. If a few things break our way, that will go to 90% this year. We have offices in the United States, Europe, and the UK. Last financial year, we achieved 4.4 million revenue, on track to hit 8 this year. And actually, my favourite stat, and to be honest, the only one that really matters, is that we've never lost an enterprise customer. So why are we here? We're not looking to raise at the moment, but we're always very interested in building relationships ahead of time. We are very interested with how we can accelerate the adoption of this technology through partnerships models. So to any consultants or advisors in the room, we think this is pretty disruptive technology, and there's very fertile ground either side of our deployment for consultants to play. If that's of interest, please chat to me after this. And the last one is generally just raising awareness of the solutions that we can provide immediately. We don't really have time for transmission builds to be delayed or for there to be existing capacity in distribution networks that's not unlocked. So it's been great to come here today and hopefully share our story. So thanks a lot.
Thanks so much, Tom. I've known Neara for quite a number of years now, and it's just so amazing to see you going from stride to stride. It's just really exciting, and congratulations on working on HumeLink, such an important part of the transmission network. Now, questions? Yes, we'll get you a mic. It's coming, rather than me running off the stage.
My question's around EVs and the potential to use this software to optimise charging infrastructure.
So it's a great question. It's potentially the next issue that we want to tackle this year. So today our focus has been on allowing network owners to understand pretty much their own networks. I don't want to speak for them, but they are kind of blind to exactly what you're talking about, that whole envelope. We don't do power flow modelling, so what we're looking to do is build an integrated network model that takes our strengths in mechanical and structural analysis, integrate that with power flow modelling, and then give network owners a really improved visibility in terms of that entire envelope for the DER and the way solar interacts with chargers. And hopefully we're bringing that online this year. We don't want to integrate with a partner that the customers or our customers, the network owners, don't want to partner with. So we're going through that process at the moment.
And one last question that's up the back all the way over there. Sorry about that.
Thanks, Tom. Great presentation. JJ here from Verescent Ventures. How much additional capacity uplift can you get from partnering with a hardware IoT device versus your software-only DLR platform?
So I think it really goes to accuracy more than capacity uplift. Ultimately, for our solution that doesn't require hardware but can integrate with hardware, if you were just looking at the software element, one of the constraints is, well, what's the input data that you're using for the relevant weather and temperature inputs? Obviously, that's going to be more accurate per transmission line using hardware. So we see it in terms of accuracy rather than a capacity uplift. If you just zoom out a little bit, from what we're hearing from our customers is actually the static re-rating at a distribution level has potentially a much greater uplift in terms of capacity than DLR at a transmission level, but I think that question will be answered over the next couple of years. In any event, we sell solutions in both, so we're not really going to pick winners. But in terms of lifting that baseline, what we're hearing is that actually static line re-rating at distribution level provides more, bang for your buck in terms of uplifting the grid.
Perfect. Thank you so much for that, Tom.